Okay, we're going to do problem number 56, and first of all, I want to congratulate you because you made it to the very last problem on the homework. And even though it's multiple choice, you're not just going to take a wild guess at it, you're actually going to sit down and figure out how to do this. So here's 56. It's a rectangle. It's inscribed between the parabolas y equals 4x squared and y equals 30 minus x squared. So we've got a rectangle in there. And what is the maximum area of such a rectangle? And again, we're going to assume this rectangle is oriented horizontally and vertically and not at some weird angle. So let's take a look at our graphs here and make sure we get those in first. So we'll start with y equals 4x squared. That's one graph. That looks good. And our second graph is, let's see, what was that again? 30 minus x squared. 30 minus x squared. Okay, let's think a little bit about our window here. We know y2, it starts at a 30, and let's see, we got to figure out where these are going to hit roughly. So 30 is opening downward, 4x squared opens upward, so it's going to be for positive y's, and x's will try something. If it doesn't work, we'll try something else. And it's also symmetric with the y-axis. So let's go from about -6 to 6. And like I say, we might have to change that. Y's, well, it's going to be positive values because our 4x squared parabola opens up, so it's going to hit the other one. And so let's include the y-axis. Let's go from -1 so we can see the x-axis. And a little more than 30, let's go to 32 or something like that. And let's count by 5s. And no guarantee in the x-coordinates here, so let's graph it and then adapt it if necessary. And there's our first graph. And there's our second graph. And I was a little more x's than I needed here. Looks like it hits after about 3. So I'm going to switch that window just a little bit. And let's go from -4 to 4. All right, let's graph that again. Yeah, still a little steep, but close enough. We will take that graph. All right, so here's the graphs that we're talking about. Let's lock that in place. And now we're talking about a rectangle, and as I said, we're going to orient that rectangle horizontally, vertically. You're not going to think of some weird angle like that. We're going to assume that this rectangle is oriented horizontally and vertically. So we've got a rectangle that looks like this. And it would come up and hit here. And it would hit here. And over there. And it should be symmetric with the y-axis. And it's kind of symmetric. Okay, well, where is it going to hit? We can call this point here x. And the y-coordinate, we will call that y1. It's not supposed to be a comma, that's a 1. And coming straight up and down, this point would also have the same x-coordinate, but a different y-coordinate. Okay, read the question. They want to find the maximum area of such a rectangle. So let's get our formula for area. I know the area of a rectangle. It's the base times the height. How about this rectangle? What's the base? Well, look, from the y-axis it goes to the right x units, and it also goes left x units. So the base is 2x. And what is the height? Well, it's going to be this y2 minus this y1. And what's y2? It is right here, the equation of that parabola opening downward. So it'll be the 30 minus x squared minus, what's y1? That's our parabola opening upward. So 4x squared. So our height was that y2 minus y1. That was our height. So we took our two functions, 30 minus x squared, other function 4x squared, and subtracted those for the height. And again, hopefully you can kind of see that in here. That's y2, and 4x squared is y1. And we just subtracted y2 minus y1 for our height. If that makes sense, I think the rest of the problem will follow fairly easily. I would say that's the hardest part here is the setup. Okay, another algebra step. Let's combine like terms. So we have 2x. It looks like we have 30 minus 5x squared. Are you thinking of the product rule? Hopefully not. Hopefully you're thinking distribute. So let's distribute. And it looks like a 60x. It looks like a minus 10x cubed. All right. To find maxes or mins, we're looking for critical points. Critical points occur where the derivative is 0 or undefined, except our derivative is going to be a polynomial, so it will be defined everywhere. So our first derivative, 60x, is 60 minus 30x squared. We will set that equal to 0. And let's give ourselves a little more space to work with here. Set my derivative equal to 0. So it looks like 60 is 30x squared. Divide it by 30. So x squared is 2. So my x coordinate could be the square root of 2 or the negative square root of 2. They're symmetric, so they're they're going to give us the same rectangle either way. So I'm going to stick with x equals square root of 2. Do you think that's a max or a min? I don't know. Let's take our second derivative. So we have the first derivative. Our second derivative looks like negative 60x. Kind of interesting here, isn't it? Let's sub in. So our area is, our second derivative is negative 60, and our x-coordinate was square root of 2. So I get negative 60 root 2. My second derivative is negative. Therefore, x equals square root of 2 is a relative max. So the interesting thing was, had we let x equal negative root 2, it wasn't really that negative root 2 that we had in our picture here, because I have to think why. And it's not that one, because that would also give us a maximum area. So it kind of fails here in that second derivative test. So I'm a little happy that I chose that positive root 2. Okay, now let's make sure we answer the question. And let's read the question again. We've got a critical point at square root of 2. We've shown its relative max. What is the maximum area of such a rectangle? Well, the easiest place to look, I think, is probably right about there. Because there's the area. And so our area, we have x is square root of 2, so the area is 60 square root of 2 minus 10 square root of 2 cubed. And the square root of 2 cubed, let's see, 60 root 2. The square root of 2 cubed would really be 2 times the square root of 2. Combine that, looks like 20 root 2. And 60 root 2 minus 20 root 2, it looks like the maximum area is 40 square root of 2. This was multiple choice. We will check our answers here. Don't have the book quite handy. And we've got 40 root 2. That corresponds to choice E, which just happens to be the correct answer, completing our problem.